Hello, I'm Wes Dyer. This is Bart de Smet, and we're here with the second episode about Rx. And today we'll be talking about how observables can be used to represent asynchronous data streams. In particular, we're going to talk about how they're like events, but actually much better. So, previously we said that Rx is three things: observables, link, and schedulers. Today we'll be focusing on the first aspect, the observable part, and how they represent asynchronous data streams. So for example, we're all familiar with .NET Events, and you know there's three basic operations you can do with .NET Events. First, you can declare a .NET event, and you can do that by saying this event keyword and then giving it a delegate type and then the name of the event. Second, you can publish data to the event by invoking the event. And the third thing is you can subscribe to the event by adding a handler. In this case, we add this lambda, right? So the three basic operations with events are declare an event, publish, and subscribe. We're all very familiar with these things. But in a similar way, we can do that kind of thing with Rx as well, and have asynchronous data streams. We can declare, publish, and subscribe. So let's look at that. So in particular, we can declare, one way we can declare an event stream is by having a subject here. We have iSubject which has ints, which basically means it's a stream of ints. Okay? So I say iSubject of int, s is this new subject thing. And that thing is now a source for creating events. The second thing is I can publish events inside that stream. And the way I do it is by saying onNext inside of s. So before I said I evoked the event e with 42, but now I'm just saying I want the next value to be pumped out of s with 42. It's the same kind of thing. And last, I can subscribe to the event stream. In this case, I say subscribe and saying plus equals, and I pass a handler that's actually the exactly identical handler to the previous slide. All right, so now let's contrast these two examples. So here we have an event e, and we have a subject s on the right-hand side, and we'll put a breakpoint here and kind of step through each of these examples. So if we start off with the program, we create a program. In each case, now we're going to add a handler. On the left, we have the event. We do the plus equals. On the right, we do subscribe. And on this slide, on this step, now what we do is we invoke the event handler or the subscribe the subject with onNext, and it pumps out the value, the next value, in this case 1. And it's going to jump to the handler, which will handle that value of 1. And it goes back to here and pumps out the next value and so on. And so actually it has exactly identical kind of behavior to what you're used to. So you're used to declaring, publishing, subscribing, and you can do the same things with Rx. But it's better than events. So it's like events, but better. And here's one of the ways it's better. So subjects is what I showed you before. And but actually, there's two different things there, right? There's publishing and subscribing. And so now we can actually separate those interfaces. So before we had this interface here that did both, but now the subject is actually implementing two interfaces. One is the publishing interface, which allows you to send messages, and one's the subscribing interface, which allows you to subscribe. And so these two interfaces are actually separate, and you can have things in Rx that just are publishers or just can subscribe and not do both, and where you cannot do that with .NET Events. Another thing is that in Rx, observables are actually first class. And what first class really means is just that we can pass them to functions, return them back, store them in values, and so on. So for example, if I have a text change stream, I can actually store that stream of strings to a variable. Or I can pass in an input sequence of stream here, and I can pass it to this function. Or I can return back the results of querying the server in an observable stream of ints. And this is what it means to be first class. Another thing is that it has punctuation. Unlike events, where events you just get all the sequence of events, you can never say like this, the event stream is now done. And so what Rx allows you to do is say next for the values, but then say completed. In other words, there's no more events. And also you can say that there's abnormal termination with some error code here, which is the exception. The last thing is that Rx actually provides a grammar and some contract around what the interface allows you to expect. So in particular, the sequence of messages you expect to see are some number of onNext messages, optionally followed by an onCompleted or onError message. Another thing is that these messages never overlap in time with respect to a single observable. So if you subscribe to a single one with an observer, he'll never call onNext. You'll never call onNext, and you'll be processing that, and then he'll call onNext again while you're still processing it. He'll wait till you've completed the first message before he sends you the next one. So for example, here's a conforming observable. It sends 0, 1, 2, and then it goes on forever. It's actually an infinite stream. This is a conforming one. Similarly, this is also conforming, but this one actually terminates with a completed message. So this has onNext 0, onNext 1, onNext 2, and then an error. And that's also good. But here's an example of one that's bad in two ways. And the first is that it sends two onNext messages that overlap in time. The second is that it actually sends a message after the completed message, which is also not acceptable. And so let's take a deeper look at what we can do with observables and how they're like events with Bart here.
Okay. So let's take a look at how we create a classic application using .NET events and how we actually do the same using Rx subjects. So let's create a new console application and just new up some event in there. So let's actually get started by creating this and adding a reference to system.reactive, which we've already used in the previous episode, so I can just include it from the recent dialog over here. So now that I'm all set up here for writing some code, let's start by declaring simply an event here. So let's say that in a classic world we want to do like a static action of int that receives some value, like the number of times something has changed or whatever. And let's actually call this event changed. Of course I will have to declare it as an event, but as you can see, events in .NET are nothing more than just delegates on steroids. So now that I have this, we can do two things with that. We can actually subscribe to the event. So I can say changed plus equals x goes to, and then write some event handler. So I can say console write line x, or I could also do change plus equals, and then just create an event handler that lives somewhere else, like in a separate method, of course, which is exactly the same thing. So now that I have an event handler sitting here, I can start raising the event, and I'd simply do that by calling to the event. In reality, you would actually have a null check on top of that and store the event object in a separate object to make sure that nobody is unsubscribing before you can actually raise the event. But so let's ignore that and just pump out 42 here. So as I execute this piece of code, you actually see 42 being printed on the console. And what happened here is that my control flow in the program really went as follows. We actually did the plus equals. We are not blocking here to wait for events to come in. We basically subscribe an event handler, and then when the event handler actually triggers, it basically invokes the code that sits in the event handler here. So that's basically what's going on in terms of the control flow. So now I can do exactly the same using iObservable and iSubject. So basically, an iObservable would be the receiving end of the spectrum here. So an iObservable equivalent would be this thing, where you do a subscribe. And the iObserver part, where you actually pump messages out, would be the equivalent to this. So let's actually take a look at how we can do that. So let's say that I have a static subject of int. Subjects live in a separate namespace called system reactive subject, so let's just include that. And let me actually call that, changed to. So I have this thing here. Let's actually create a new instance of that, and now see how we can actually change our code to use a subject instead. So instead of doing plus equals, instead of doing that, I'm going to use subscribe. And so if you take a look at subscribe, there is a number of overloads that you can use. The master overload is actually the one that takes in an iObserver, which is the way to receive data. It's a callback interface that has onNext, onError, and onCompleted. But we also have overloads here that come in into extension here, or into existence by means of extension methods from the system namespace. You can actually also use the overload that simply takes in an action of onNext, which is exactly what we've been doing for the .NET event. So that's the equivalent to plus equals with .NET events. Then in order to raise the event, instead of calling to the object, which you can't do because it's not a delegate type, you would do onNext instead. So you can say change to.onNext42, which means invoke the onNext handler on anyone who subscribed to this particular event. And so as I execute this, we see exactly the same control flow sequence here. We see that subscribe is asynchronous. You basically subscribe and then you move on with the rest of your program. And then at the point that you do an onNext, you see that the event handler actually will get invoked and will actually have console write line sitting on the screen here. So you see that now coming out of the application. Now because we've done this, just one thing to notice here is that if we include, and we'll talk much more about that in the next episode, if I include system reactive link, because a subject is actually an iObservable, we can start writing queries over that, which is already strictly more powerful than .NET events. So if you look at change to dot, you see a whole set of operators that you can apply to this event source to do all sorts of event processing on top of it.
We should maybe also show unsubscribing real briefly too.
Exactly. So unsubscribing is also quite different between .NET events and reactive because, well, there is something a little fishy with .NET events with regards to unsubscribing. If you want to unsubscribe from a .NET event, really what you're doing there is you basically have to memorize the thing that you gave to the plus equals here. So like here I'm subscribing to the .NET event by giving it this particular delegate. However, how do you unsubscribe from it? Well, you will have to store this part that you have sitting here in some separate delegates, like let me call this thing A. Oops, excuse me. Let's actually undo this and actually cut it out. So in order to unsubscribe, you need to memorize the thing that you actually gave to the plus equals. So something like this. So you can do changed plus equals A, then you can invoke the event like this, and then in order to unsubscribe, what you have to do is you have to do changed minus equals A. You can't just copy in that same delegate type or that same delegate piece of code because, well, the compiler will generate two of those and they will not have the same identity. So you can't actually unsubscribe by just copying the same piece of code here. You need to memorize that action somewhere. Now with Rx it's kind of different because what you do there is you basically say change to .subscribe. And as you will see in just a second here, let me actually inline this whole thing again. The way to unsubscribe is not by memorizing the action. Actually, the keys on Wes's keyboard are slightly different from mine, so apologizes for that. So I can do this, but as you can see on change 2, if you sort of go for a hunt for unsubscribe, you won't find that. There's no way to unsubscribe apparently by calling an unsubscribe method, which would imply that you would have to memorize the action. Instead, what you get is when you subscribe, the return type is a disposable. And so when you actually assign that disposable over here, you can call d.dispose at the point you want to unsubscribe from the event source. Let's actually do that over here. D.dispose means basically eliminate that particular subscription that we have sitting there on our event source. And so just to prove the point that this is actually working, let's do change to on next 42, and let's do changed 43 over here. And you will see that the second one shouldn't come out because we've already unsubscribed from the event source.
That's right. Yeah. All right, so we promised you that we'd end with a challenge. And so indeed we do have a challenge with this episode. And that is, we've talked about all the ways that observables are better than events. But one way we haven't talked about them, only briefly, kind of Bart has mentioned it, is that observables are more compositional than events. And the challenge is essentially to prove that fact. So if you open up challenge 1, the introduction to Rx challenge, then what you'll find is there's a little program here that has some output, and it basically has the, let me bump up the font here. It has things for events, and it has some code, the same code for observables. And basically what we want you to do is that in the event-based one, for example, you'll see that there's a text changed event. What we want you to do is implement the event for length changed. And the text change was a field-like event. This is a virtual event. And we want you to implement this using only the add and remove text here, and not adding any more stuff on the outside except for maybe a field. That's a hint.
So length change needs to basically listen to on text changed.
Yes.
And you know, whenever the length of the text is actually changing, you need to pump out a value saying what the new length is.
That's exactly right. And observable is the exact same thing. We have a text changed asynchronous data stream, which is of strings, and now we have a length changed one, and you can implement this one as well. So the challenge is to implement these, and once you've done that, you will see for yourself why observables are compositional and events are not. So thanks, and we'll see you next time.